Today we are going to discuss a model designed and created to study the combination of electrical vehicles and intermittent renewable energy sources. This model incorporates environmental self-identity and range anxiety as agents variables to explore how policy interventions can encourage EV charging during renewable energy surpluses. So, could you please introduce yourself before starting the conversation?
Sure. Hello, I'm Mart van der Kam. I'm currently a postdoc at the University of Basel. My expertise is modeling of human behavior in energy systems. And the model we are discussing today, I developed it during my PhD at Utrecht University in the Netherlands.
So to start, could you please explain the main purpose of this model and what inspired its development?
Yeah. So we were interested in the role that electric vehicles can play in the transition to clean energy and transportation systems. And for that, it's not only important to adopt electric vehicles, but also how do you use these electric vehicles? For example, do you charge them with renewable energy or energy from coal power plants? At the same time, by being a flexible source of flexible energy demand, electric vehicles can help the integration of renewables in the energy systems. So we were interested in exploring that idea. And in addition to like other studies that were there on this topic, focus not only on the technical challenges or possibilities in this integration, but also model the human factor in this. And so for that, we did a collaboration with psychology researchers from the University of Groningen and used their theory of drivers behind environmental behavior to model the behavior of the electric vehicle drivers in this model. So we combine both technical and social aspects in the model.
So let's talk about the development process of this model. What were some of the main challenges you faced while developing the model, and how did you address them?
Yeah. So I think anybody who's worked on interdisciplinary projects will recognize that one of the first challenges you encounter is to understand each other. For example, what I mean as a modeler with a model, or what a psychology researcher means with a model, usually is quite different. And also, models are of course very formal in terms that every kind of step that you of a behavior in a model, you need to have it implemented in code. You can't be vague about this. And so, for example, one challenge in that we encountered, so in our model, the agents have an environmental self-identity that says something about the extent to which they identify as an environmental person, somebody who acts environmentally friendly. And there's a lot of research on how different interventions can strengthen this self-identity in people, but not so much about how it can be weakened. And for a model, this was also important because in the end, you would end up with people that are super environmental friendly. And of course, this is not what we see in real life. There also needs to be a counterbalancing force. But there was less research on that. So we had to make some assumptions on that. And to identify that and to handle that, that was, I guess, a main challenge in this model.
Moving on to the results of this model, what are the insights coming out of the model analysis, and how can these results contribute to our understanding of charging behavior of drivers?
Yeah. So there were results at several levels. So on the one hand, we did a comparison of what happens if you have a lot of renewable energy compared to not so much. What happens if you have more solar or more wind? What happens if you have a lot of infrastructure or it's more limited? Or when people with social charging also share a bit more the limited infrastructure or not. And can you force people to only charge with renewables? What happens in that case where you have some financial incentives? And finally, the most interesting aspect, I think, of our paper was to say, okay, what if you just provide people with information? So you don't force them to charge with renewable electricity or whenever they want. That's the kind of the main dilemma or choice we have our agents make. But you provide them with information and also information. Okay, so for example, if you charge with 60% renewable energy, you get this information, and then maybe you start. That's what theory says, at least. Then that makes it more likely that in the future you will choose even more to charge with renewable energy and so on. On the other hand, we also had it also works the other way around. So if you never charge with renewable energy, then you think, okay, I'm I'm not somebody who's very environmentally friendly. So also in the future, I will not do that anymore. But there's another factor, which is range anxiety. Is an well established as an important factor in psychology around charging behavior. So what if you're super motivated to charge with electric energy, with renewable energy, your electric vehicle, but then you run into problems because you didn't charge enough. For example, because in the winter time there's less renewable energy, so you are super motivated, but it ends up with you being stranded on the side of the road. And this we have in our model is then a very is very demotivating to continue the same behavior in the future. And in cases where there's not an abundance of renewable energy, you see agents making different moves in terms of how much they charge with renewable energy or any kind of energy. And so, for example, one of the things our model then shows is, okay, you may want to motivate people to act environmentally friendly. But if you do it in a context where they run in a lot of problems with doing so, or potentially in a lot of problems, they get stuck in a place where I act environmentally friendly by charging with renewables. It leads me to problems. I get stranded on the road. Now I'm not interested anymore for the future, even if then the context improves in the future.
You used ComSys.NET platform to make this model available. So, can you tell us about the challenges you faced in the process of using ComSys.NET to make your model available, and what did you do to address these challenges?
Yeah. I'm not sure if I would call them challenges necessarily, but of course, like when you publish your model, the most important thing is that you make it accessible on different levels. Um, so not just why did you develop the model, why would it be interesting to somebody else? Those are of course, important things to communicate, but also that when somebody's finally using your model, that they understand everything which is going on. And when I published it, I received actually also some emails from different people who were working with it, and yeah, people once they start working, it can really go into detail. And for example, I also had an email of a student who also pointed out some bugs in the model that he and even suggested a solution for. But this is just to say that, well, then I guess the challenge is if people are interested, you can assume that they use it in a very detailed manner, also to maybe tailor it to their own specific needs that they see. And how to do it. So there are several steps. So of course you can make your own effort to write the code as clearly as possible. There's also the ODD format to provide both the kind of main theoretical ideas about your model, but also the full implementation, which can really help people and also help yourself to really think through about what you did. The review process can also help. I've also encountered also in the review process for ComSets, I got quite detailed comments sometimes about, okay, here's this little line that you need to fix, so that also works on my computer. So those are the different solutions, I think, to help that.
Finally, looking ahead, what is next with this model and research, and are there any follow-up studies available or planned to, I mean, expand on your current work?
Yeah. Um, well, so for this specific topic. This is the study, and I've moved on to different projects. But in the overall, but I'm still working on the same kind of overall topics. And one of the things that I was very excited to work on was because in this model we use a theory from psychology, environmental psychology, but we did not have the data to incorporate it. So basically, we have a number of variables in there that we think should more or less work like that, and then do a sensitivity analysis to explore. Okay, but what if it's very different? What does it mean for our results? In a project I was working on here in Switzerland, we worked not on the charging behavior of electric vehicle drivers, but the adoption of electric vehicles in combination with solar panels and also heat pumps. And there we had the resources available to also gather data, do our own survey to inform this agent behavior. And I think the most significant step then compared to this model is the integration of actual behavioral data in the model to increase the empirical grounding and the reliability of the model as well.
Thank you for joining me and sharing your insights on this interesting model.
Thank you, and happy to participate.